Hey there. We're going to start out today with the different biomes that we need to know. There are different types of biomes, and we also need to learn about how climate and weather affect them and what succession is. So let's do a little recap here. So what is a biome? Okay, a biome is a group of similar ecosystems that together have organisms that are adapted to a particular climate and cover a large geographic area. Okay, so biome is the largest area where, the animals and the plant life is kind of the same and they have the same kind of climate. So like a big desert or the polar region is a biome, okay? So let's just do a little bit of review here. So let's do a little mini quiz. You can keep track of how many you get right. You might get them all right. Okay, so which biome has more species than all other biomes together and gets at least 2 meters of rain a year? That's like 6 feet of rain. Is it a desert, tropical rainforest, grassland, or savanna? All right, if you guessed tropical rainforest, you are right. Give yourself a little point there. Okay, the next one. Which biome receives less than 25 centimeters of rain a year and undergoes extreme temperature changes daily, meaning that it gets very hot and it gets very cold? So is it a savanna, temperate forest, desert, or tundra? If you guess desert, you are right. You guys, the desert can, of course, get to sometimes 120, 130 in the day, maybe even higher. And at night, it gets below freezing a lot of the time. It gets really cold in the desert. Okay, the next one. Which biome receives seasonal rainfall where there are mostly grasses and shrubs, and animals must migrate during dry seasons to find water? Savanna, boreal forest, tropical rainforest, or temperate forest? Okay, if you said tropical savanna, you are right. And you can see the zebras in there. Okay, the next one. Which biome consists of mostly grass that are resistant to grazing and fires? It's either a temperate grassland, tundra, temperate forest, or boreal forest. Okay, temperate grassland. If you said that, you are right. Those little guys, the little, I think those are prairie dogs. I wanted to say gophers, but they're prairie dogs. Those are my favorite things to go see at the zoo. They're so cute. Okay, which biome has a layer of permanently frozen subsoil called permafrost? Is it tropical rainforest, boreal forest, temperate forest, or the tundra? Okay, if you said tundra, you earned a point. Okay, which biome has dense forests of evergreens? Evergreens are the needle trees with long, cold winters and short, mild summers. It's either the boreal forest, temperate forest, tundra, tropical rainforest. Remember, it's got the needle leaves, evergreens. Okay, that's the boreal forest. That's just north of us, into the Canada area. Okay, which biome has forests that consist of deciduous? Deciduous trees are the ones that lose their leaves. They've got the flat leaves. And evergreen trees, the kind that have needles. So which biome has forests that consist of deciduous and evergreen trees and have a rich layer of humus? Humus is the soil. It gets lots of nutrients in it, and that's what it means to be rich. Okay, so is that the temperate grassland, savanna, boreal forest, or temperate forest? There you go. That looks very similar, doesn't it, to like what we live near? Okay, it's got both the broadleaf trees, which is the deciduous kind that lose their leaves in the winter. It's got pine needle trees or evergreens, and it's got the nice dirt that has lots of nutrients in it. Okay, so these biomes have weather that occurs. And weather is really just the day-to-day conditions of the Earth's atmosphere at a particular time in a very small place, okay? So our weather today might be chilly, it might be rainy, okay? But it's just for that moment. That's what weather is. Climate, on the other hand, is when you take that weather average of an area over a long period of time. So if you can look in the left, that climate is going to be hot for long periods of time, like most of the year. The next one, it looks like a drought has been happening. So maybe it rained yesterday there, but over time, the average is super dry, okay? So again, weather means just a snapshot in time of that local area. Climate is over a broad array of time, like a whole year maybe, what the average of that area is. Okay, there are climate zones. All right, so when we look at this map, we've got the northern part. See here, this is the polar zone. Notice it's all pink up there, if you can see the color. That zone, the polar zone, and this polar zone are very similar. That's due to the tilt of the Earth, okay? Then we have the temperate zone, this kind of between 60 degrees north and 30 degrees north. It's kind of that orangey color. There's another temperate zone down here towards the South Pole. And again, due to the tilt of the Earth, that makes these two areas similar in their climate. This middle part, the equatorial area, that is called the tropical zone. That's where the tropics are, okay, due to the tilt of the Earth. Okay, so during summer in Minnesota, we look at the sunlight that hits the Earth's surface. In the summer, June 21st, the sun appears to be almost directly above us. Here we are standing on the ground and we look up and the sun is really high in the sky. Now, if you go to September 21st, so really close to what we're at right now for time, the sun appears to be down lower in the horizon, okay? It's not so directly above. When it's directly above, it's going to get hotter during the days. When it's tilted, our Earth is tilted a little bit, we see that the sun goes down in angle. Therefore, it's not going to be as hot here. So right now it's cooling down. And in another few weeks, it'll be December 21st, and the sun will be at a very low angle. Therefore, we don't have as much heat hitting us. Okay? So the more direct the sun is beating down on us, the hotter it's going to feel to us. All right. So let's look here. During the winter months in Minnesota, the sun's light is hitting the surface at an angle and we have fewer hours of daylight. Okay, we're going to look at that in the next slide. Here we go. This slide is showing, here's the sun right in the middle. Okay, the sun is pushing its rays out, and here is the Earth in June. Notice the Earth is tilted on its axis right here. Okay, the Earth never really changes. Look, it keeps the axis pointed in that same direction all the time. The only thing that's changing here is our location from the sun. So it's going in this direction. So June in the summer, notice because of the tilt of the earth, the sun's rays hit this northern part of the world more directly, and the world keeps spinning, spinning, spinning. Each day it spins once. Whoop, there's one day, 2 days, 3 days. Okay, but after 3 months, the Earth has been traveling around the sun, and after 3 months, the Earth is over here. That's where we are right about now in the fall. And look at the North Pole is now in the shadow. It never sees the sun up there at this point, at the very North Pole. Okay. So the sun appears to be a little farther down on the horizon. Now, 3 months later, December 21st, here is the Earth, here's the sun. Look up here. This is the northern part of the North America, is up in this shadow, and no matter how much and how it turns, it's turning 1 day, 2 days, 3 days. It's always in the dark. That's in the winter time. Down here at the South Pole, it's always light. So if you were to go to the South Pole December 21st, you would never see the sun go down, right? Okay, 3 months later, we're in March here. We're still going around the sun, and we see it's going to be very similar to this one. It's just on the other side of the sun. And then we get over here, and it's summer again. Okay, so now let's look right here. In summer, what would it look like at midnight in Alaska? Alaska, there's Fairbanks, right there, right where the tip of my pointer is. That's where my sister lives. That's where I visit every summer, right around that time. So right there, what is it going to look like as it twirls around the axis? There's 1 day. There's 2 days. There's 3 days. I'm vacationing up there. Am I going to see the sun go down when I'm up there? No, I'm not. Not if I'm up there at that time of the year. When we look at midnight in Fairbanks, Alaska, this is what it looks like. That's my sister's backyard. Here it was July 13th. So it's a little later, but that's okay. I never saw the sun go down. Now, what if I were to visit my sister in Alaska right there, December 21st? Would I see the sun go down? Well, the sun would be down all the time. Look at that. It is constantly dark up there during that time of the year. That's why my sister never wants me to come visit in Fairbanks in December. Okay, the greenhouse effect. All right, so the greenhouse effect is, if you look at the definition on top, carbon dioxide, methane, water vapor, and other greenhouse gases that trap heat energy. So the sun, its rays enter our atmosphere. Here's the edge of our atmosphere. And we have these gases that are from the ground up. Those gases let the heat in, and those heat molecule, or the heat bounces off the molecules of these gases and heats them up a little bit. Now, you don't want too many of these gases in our atmosphere because then it's going to keep heating up, heating up, heating up. And that's what most scientists believe is happening with climate change. Some areas are getting more heat happening. It's changing the climate of our world, of these different biomes. It doesn't mean it's always going to be heating up, but it does change the climate. Okay? Now, if we didn't have this greenhouse effect, what if we just had no atmospheric gases at all trapping heat? What would it be like here on Earth? Think about that. It would be really cold. We want the greenhouse effect here, but we just don't want too much of it occurring. So things that actually create these gases are deforestation when they burn up the forests. That smoke in the air helps to create the greenhouse effect more. CFCs, those are called chlorofluorocarbons. Those were in spray cans. We have changed that in the United States. We do not use what's called CFCs anymore. We use a different kind of chemical to bring on the same effect, but a lot of countries still do use CFCs. Our car exhaust. We are going to electric cars now because they don't have any kind of exhaust that comes out, because we don't want to keep adding more of these chemicals to the greenhouse effect. Factories, all the smoke that's coming out of them, not a good thing. So we are changing things. We are making it better. Over the long run, hopefully we make it even more and more better by changing our habits and changing our technology. Okay, succession. Succession is the gradual change in populations of organisms that occurs when the environment changes. So, like when I grew up here in Minneapolis, and the environment was different back then. Like down along the creek, it looked different than it does now. Things don't stay the same over a long period of time. They succeed in this kind of a direction. So, first of all, you have these shorter, smaller plants, maybe grasses. Here it says, a fire or some other disturbance clears the land. And then after a few years, or maybe even just a few months, stuff starts to grow again. Then over time, you have bigger, larger brush, larger bushes, and over several years, our trees start to grow up taller, and then we get an old growth area where the trees are all very old and big, and then you've got some smaller bushes down here. But that is what succession is, an area that successes or succeeds into an older growth area. So how the ecosystem changes over a period of time. Grass comes in first, bushes will outcompete grass, and then trees outcompete bushes. and so on. So there are two different kinds of succession that we talk about. One is primary succession. Primary succession on a volcanic island will start with rock. There's like absolutely no soil there, no life. And then after a while, if it's able to cool and sit there for maybe years, the soil will start to show up. And that might happen because of weathering on those lava rocks, and it breaks it down into a soil. Or we have nutrients coming from the oceans going up onto that lava rock and dissolving and becoming better nutrient rich material, and combines with the weathered lava rock, and it becomes a soil that plants can start to grow in. And maybe a seed comes over from the wind and it starts to grow some plant life. So that's primary succession, when it starts out with absolutely no soil. Secondary succession is when it already has a soil base. So here we have, in this first picture, a fire has occurred and it's destroyed all the organic matter there, like all the living things. Okay, so it's kind of going back to the beginning, and then grasses start to grow after several months maybe. And then after a little bit more time, bigger grasses grow and some brush grows. And then after even more time, the trees start to grow and take over.